ask me. Thank you.
Thank you. The next presenter is Iustina.
Hello, everyone.
Hello.
Can you hear me?
Yes, we can hear you.
Perfect. And this student is Today I'm presenting deep learning for activity detection and decision support in sport climbing. First, I will present content of the presentation. I will talk about sport climbing in general, then how we came up with the modeling climbers' behavior. Then I will talk about activity recognition via sensors and deep learning, and short talk about pose estimation and object detection. Sport climbing became a popular sport since inclusion to Olympic Games. Every year, new climbing routes around the world are built, and choosing the right climbing route is not simple. We came up with a research problem, which is dealing with modeling climbers' behavior. We propose to model climbers' behavior via explicit feedback, which is data coming from mobile application used by climbers, and implicit feedback, which is data coming from accelerometers and web cameras. We would like to use this data in order to build climbers' profile and further to understand climbers' preferences and needs, and further to build recommender system for climbers, recommending which climbing routes to climb. Up till now, we detected activities in climbing gyms, and we detected it via sensors and also via web cameras. We were able to detect activity of lower and activity of rope pulling, which is useful in order to understand how many climbs climbers did and also how fast and how well they climb. Then we applied pose estimation for activity recognition, where we net pose estimation. On the right figure, we can see, on the right video, we can see climbers who climbed in the climbing wall and bounding boxes which were detected climbers during their climbs. On the right figure, we can see the trajectory of 5 different climbs, and we can see that there are outliers, which shows that neural network was not stable in detecting bounding box of climbers, and we applied smoothing, where we deleted outliers. And on the last figure, we can see the trajectory of climbers, and the maximum of this graph shows the points where the climbers reach the wall, the top, and activity of lower started. The green point shows us the time point when the activity of rope pulling started. X-axis shows us the timestamp, and Y-axis shows us the pixel where the middle of bounding box is located. And then we applied I don't know why it doesn't go further. Okay. Then we applied object detection for activity recognition in climbing wall. And here we can see the objects of quick draw with rope and without rope. Quick draw is a special type of climbing equipment which is used by climbers for safety reason in the climbing wall, and when the quick draw has a rope, that means the climbers is climbing. When the quick draw doesn't have rope, that means climbers is not climbing anymore. And on the top figure, we can see trajectory of climbers who climbs, and on the bottom figure, we can see the target quick draw with and without rope. We applied this curiosity net to detect objects, and we were able to detect with 98% accuracy of the objects. And when the target quick draw is not with rope anymore, that means the end of activity of rope pulling. As I said, the activity of rope pulling is useful to detect the number of climbs climbers did and also their performance, how well they performed. Further on, we would like to build a recommender system for climbers based on the activity detection and also mobile application. Thank you very much for your attention, and if you have any questions, please ask me via email or during the coffee break. Thank you also for organizers to give me opportunity to talk today.
Thank you. Okay, so we have no more presentations for today, and thank you all.